Let's talk about function notation. Function notation can be a little bit weird, but it's actually very, very helpful, and it's not so bad once you get used to it. Let's say I have an equation like this, maybe just a normal equation, y equals negative 3x plus 1. And then maybe I ask you to evaluate, tell me what y is when x is 5. You could do that. Y is negative 3. I'm just going to put the 5 in the x spot. And then from here, I just crunch some numbers and I find out that y is negative 14. Well, that's great, but down here, if I just tell you y is negative 14, there's nothing that tells me what x value I used to get to that negative 14. So I then have to go somewhere else to look to see what x value I started with. So function notation is nice because it keeps everything together. So function notation is just going to rewrite your y. So I had before y equals negative 3x plus 1. Instead of y, we're going to write this as a function, and I'm going to tell you what we're plugging in on the other side of the equation. So this function is in terms of x, meaning my y values depend on what x values we put into the equation. So all I did is I rewrote my y value using what we call function notation. Now if I want to plug in a 5, I take my function and I put a 5 in for all the x's. Remember that this whole thing means y, and now I'm telling you what x value I'm using to get the y value that I want. On the right, I go ahead and I put the 5 in for the x. The function of 5 is negative 15 plus 1, so the function of 5 is negative 14. What this means is that y, remember this whole thing means y is negative 14, but the nice thing is I also tell you what x value I used to get negative 14, so I can see the 5 as part of my final answer. So let's try a couple. I have this function f of x equals 3x minus 6. So this function is in terms of x. Or in other words, we can say I'm going to find some y values depending on particular x values. The x values that I want to look at are 3 and negative 5. So let's go ahead and start with my 3. I'll take my function f of x, and I'm going to replace all of the x's with my input, which is a 3. F of 3 equals 3 times 3 minus 6. And remember, on the left-hand side, this is just y, but I'm reminding you of what x value we're plugging in. So that notation is y when x is 3. On the right-hand side, I go ahead and I just evaluate. So f of 3 is 3, meaning y is 3 when I put in the input of 3. So when x is 3. So all of that information is condensed into this one statement. Let's do it again. I'll plug in my x is negative 5. I take my function and I'm going to replace all of the x's with a negative 5. F of negative 5 is 3 times negative 5 minus 6. And then I just simplify that right-hand side. Negative 15 minus 6. F of negative 5 is negative 21. So I have my y value. Remember, this is all y equals negative 21, but I also remind you what x value we used to get there. The x value is negative 5. So all of this tells us that y is negative 21 when I use that input of negative 5, or when x is negative 5. That is all from this one line. That's a little bit about evaluating functions. Thanks for watching, and I'll see you next time. Bye.